Now what we want to do is jump a little bit more detail. We're going to get in the entire course into so much detail, solving tons of problems, but I want to give you a roadmap to show you a little bit more about these topics. And we're going to get a nice overview of that. So when we talk about motion, first thing we're going to actually talk about in physics are the equations. The equations of motion. And to simplify it further, we're going to actually talk about motion only along one direction, one dimension we call it. So we're not going up and down, we're only going left and right because it makes things simpler at first. So you'll see 1D motion, you'll see you have 2D motion when you have like a throwing a ball up in the air and also horizontally. And then of course we'll have 3D motion, which is the real world, you know, when things can move left, right, up, down, backwards, and forwards. But really the equations are all very similar. So we start out by talking about what happens in one direction, only when the object can only move basically backwards or forwards. And I'll tell you, this thing called equations of motion scares a lot of people, but you already know a simple equation of motion, and that is what? What do you know about velocity? I know we haven't really talked about velocity in this class. We're going to talk a whole lot about velocity, but you already know that in a car, when you're driving, it's miles per hour, right? Or kilometers per hour, right? So the velocity that you're traveling is the distance over the time. How far did you go? How long did it take? You divide those numbers, you get something called a velocity. Now, if you remember a little bit of algebra, this is a fraction, so I can actually get rid of the time on the bottom by multiplying left and right-hand side of the equation by time. So on the left-hand side, I can get velocity multiplied by time, and on the right-hand side, that will be just distance, which is left over. Now, if you don't totally understand how I got there, this is just a little bit of algebra. I multiply the right-hand side by time, which cancels time and time, leaving distance. I multiply the left-hand side by the same thing, time, so I have velocity times time. This equation makes sense also because when you think about it, if I know that I'm traveling down the road at 45 miles per hour, we don't typically use miles in physics. We're going to learn about meters and all that, but if we're going a speed or a velocity of 45 miles an hour, and I'm traveling down the road for 2 hours, how far did I go? Think about it. I'm going 45 miles every hour, and I'm multiplying by the 2 hours because, you know, every hour I go another 45 miles. So that should be clear that this is 90 miles that I've traveled. This thing here, distance is equal to velocity times time, that's just a very simple equation of motion. So don't let these words confuse you or scare you. Equations of motion, it sounds really difficult, but you already have experience with basic equations of motion. You know that the distance you go is going to be how fast you're going times how long you're traveling at that speed, how the time involved. So what we're going to do as we go on is we'll just have more complicated cases. We're going to figure out, well, what's going to happen when I have gravity involved, if I'm dropping something? What's going to happen if I throw something? What's going to happen if I have friction, right? Then the equations of motion are a little more complicated, but it's the basic same idea. So for instance, in 2D motion, I might actually throw something like a baseball or something. I might throw something up here at like 39 meters per second. So I'm using the same thing. It's a velocity, but it's meters instead of miles, meters per second. So you all know that if I take a ball and I throw it at an angle, right? So let's say I'm throwing it at some angle here. I'm going to call that angle theta. That's just a variable that's talking about the angle, or I can just take out the variable itself and just say, well, I'm tossing it at 25 degrees from the ground, right? What's this thing going to do? I mean, you all know that if I do that, it's going to continue up, it's going to hit some maximum, and then it's going to come down, and it's going to hit the ground again. So the question is, if I throw a ball at 39 meters per second at a certain angle, what do I want to know? Typically, I want to know how high did it go? That's what I want to know. How high did it go? And I want to know generally how far did it go? And I'm not going to write it on the board, but I also probably want to know how long was it in the air. So that's called projectile motion or 2D motion, and it's just going to be basically an equation of equations of motion applied to that situation, right? Now what we're going to actually do to solve these kinds of problems is we're going to take this 39 meters per second, I'm going to blow it up for you down here. If I throw something at an angle of 39 meters per second, right? And I'm throwing it at some angle relative to the ground, 25 degrees, let's say right here. it actually is kind of complicated to deal with 39 meters per second at an angle, right, all at once. So what we typically do is we actually break the 39 meters per second at that angle, we break it up into two parts. We break it up into how fast is it going horizontally, right, the horizontal part of the motion, and how fast is it going up and down, the vertical part of the motion. So I might have, as a result of this, might have a vertical part. See, it kind of comes over to where the tip of the arrow is. So this is going to be a vertical part of that motion, and this is going to be a horizontal part of the motion. So what I'll do is I'll apply the equations of motion, which we'll learn later, to the up and down motion by itself, and then to the horizontal motion by itself, because anytime you throw anything, if you throw it steep, if you throw it shallow, you can always break the motion into horizontal motion and vertical motion. So it's easier to solve these problems by solving the horizontal part separate from the vertical part. So we're going to learn about that. And this concept here, splitting it up like that, that's called a vector. And we're going to learn about vectors in great detail because they're going to be one of the big tools that we use in our tool bag to solve problems. Now, the next thing we learn in physics typically is the concept of energy. And I know that most everybody here has an idea of energy, but we're going to talk just a brief minute about energy. So the best way I can describe energy is, or at least one type of energy, is a roller coaster. So here's a roller coaster, very high hill, and then comes down to the bottom, and then a little bit like this, and then maybe it just kind of does something like this. So there's a car, it clink, 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 gets to the top, very, very, very high, right? At the very top of this very high mountain, right, we say that it has a high potential energy. High potential energy. I don't have room to write out potential energy. But the reason it has potential energy at the top is because we're in a gravity field. So if you bake something very high off the ground, if you were to drop it, it has a high potential to accelerate down to the ground and to hit the ground, right? So to do something, to hit the ground, to have to do some impart some energy into the ground. So we say it has a high potential energy here. So what happens is the roller coaster goes to the very bottom, and all of that potential energy you have, because you're accelerating, when you get to the very bottom here, when the roller coaster starts to round the bottom down there, we say that we have a high kinetic energy. So we're going to learn a lot about potential energy and kinetic energy. Kinetic energy is how fast you're moving. It's the energy of motion. So you know when you get to the bottom of the trough here in the roller coaster, you're going fastest. Up here, you're going slow. So you have very low potential energy here, high potential energy here, and it's all converted into kinetic energy. And then here, over at this part, what do you have? Well, you have medium potential energy, because you are a little higher off the ground, but not as high as here. And you have medium kinetic energy, because you're not going quite as fast as you were down here. You bleed off some of the speed. So one of the big things we're going to do in physics is we're going to talk about the total energy of a system. And the total energy of a system that moves like this anyway is the potential energy plus the kinetic energy. And the total energy of the system actually doesn't change, because whatever I start the system out up here at the top is how much energy I have. It's just all in potential energy form. So at the very top of the hill, I have a very high potential energy. That's what the up arrow means. And I have a very low kinetic energy up at the top here. But then when I get to the bottom here, I have a very low potential energy because I'm basically at ground level. And I have a very high kinetic energy because I'm going really fast. So you see what's happening? Every time the potential energy gets high, my kinetic energy must get low. And every time the potential energy gets low, the kinetic energy must be high. So it's like a trade-off. It's like 2 cups of water. I'm pouring the water in here. Now the energy is over in the potential energy cup. Then I pour some of the water back in over here. Now the energy is all in this cup. And if I pour half and half, I have half of my energy in the potential energy cup and in the kinetic energy cup. That's basically here. So the trade-off between potential and kinetic energy can be used to solve tons of problems. And we're going to spend many hours solving lots of problems involving potential energy and kinetic energy. Okay? It's one of the big